All right. Here is an example for B plus tree insertion and deletion. I'll share the link to this visualization under the video here, where you can go ahead and play with it as well. So I saw this as a neat little visualization for learning the idea of B plus trees. So let's go ahead and start creating a B plus tree. So we have options to keep the max degrees. So here we'll restrict it to 3. So that's the number of pointers that we were talking about. So let's see what happens with max degree 3 when I start inserting people here. So let's for convenience I'm going to use the names as A, B, C, D rather than Mozart, Einstein, Gold and so on. So please bear with me. So I have A here. Let me see if I can zoom this somehow. Uh, okay, so I hope this is visible to you now. So let's insert another node B, and let's insert another node C. So you see that I cannot have another node C along with A and B because the max degree is set to 3. So there is a pointer before every data item, there is a pointer after every data item. So the maximum number of data items I can have is only 2 if the max degree is 3. Now let's so what happened, so basically when I added the third item I had to split the node. So let me delete C once again. So let me see if I can go back. So I think okay, so let's do it from the beginning. Let's clear everything. So I have A, I have B, so no problem still here. So so now I have a B plus tree node with 2 data items. The pointers are not pointing to anything because there's no child node from here. So assume that at the moment there's only a pointer which points directly to the table where the row with A exists, and similarly there is a pointer before B which points to the table where the B row exists. So this is all we have right now, and the fun starts when we start inserting C. So obviously I cannot put C after A and B, so I have to split it. And the best way to split it is to split in the middle. So keep the B at the middle and then have A as another node and B and C as another node. So we do see here that at every level, the data gets repeated. So that calls for additional space usage. So that's one other disadvantage of using a B plus tree. Now let's insert D. What happened just now? Let's skip back. So I want to add D. So I come to the root. D is bigger than B. So I come here. I would like to add D to this node, but I cannot because the max degree is set to 3. So in order to add D, I have to split this further. But how do we split it? Fortunately, we don't have to create another child node here. We would not like to go deeper and deeper. We will only create new levels if the current level is full. So here the current level is not full because there is some space on the node which has A. So I can shift B here and I can keep C and D here. So let's see if we can do that. So I'm inserting D. So I can shift B and then I can have D over here. For convenience, I create another node B so that if I'm looking for anything, so here the convention I'm using is if I'm looking at anything less than B, I go to the left child of B. And if I'm looking at B or anything above B, I take the right child of B, right? And the next one, of course, I have to compare, which is C, and anything less than C, I should take the left child, and anything that is C or above, I should take the right child. So let's now try inserting E. Okay. So now what do I do? So when I put E here, again I get into, so let me skip back. So if I try to put E, I cannot add it to this node. So ideally it should go and sit at the end of the last node, but I cannot do that here. So I will have to split. How do I split? Well, as I told you, the rule is simply to kick C out and then accommodate E. So that's what we did now. So we kick C out and put D and E. So this is clear, and this is the leaf node. So of course it has all the nodes with a pointer from one node to other. So this part is clear, but something happened above. So let's try to understand what happened here. So I'm trying to insert E in this state. And if I add E, I would like to get C out and D and E together. But remember, if C is out and D and E are together, I told you that the right child of C should point to C and above. So this here should be pointing to the new node C, right? So if this has to point to new node C, then how would we connect D and E to this node? Now to fix this problem, we split BC as well. So let me show once again. So that's what has happened. So we want now we want to keep C as the middle or the root node, and then we have anything less than C comes over here, C and above you go to the right, and you get D. So anything less than D you come to the left, anything D and above you go to the right. So that solves the problem for us. Let's play around with max degree 4. So max degree 4, let's say A. So there's no problem with this. For B, again no problem, I can just add to that. C, again no problem, I can add to A and B. Now what happens when I try to do D? I cannot accommodate D, so I need to split the node. Um, Now that I need to split the node, I have to go for another level, and from this level, of course, the middle one remains at the top since we have a clear median element. So we keep C, and anything less than C is on the left, anything C and above is on the right. So this is how it works. Now let's add E. So what do you think will happen to E? So E is C and above, so it should just get added to this node. Okay, so we have no problem so far. Now, if I were to add F, I would like to add it here, but I cannot since the max degree is only 4. So I can only accommodate 3 data items here. So if I want to insert F, ideally I would like to do this, but I cannot, so I have to split. So I split it into half. So we have CD and EF. Now since I have split it into half as CD and EF, I can add one more index data item over here. So I have C and anything less than C, I mean anything less than C on the left and C and above on the right. And now that there is E, anything less than E is on the left, and E and above is on the right. So everything works good. So this is the interesting part of creating the tree. So now let's go on. Let's add G. So G should get added at the end here. That's it. Let's now try to do one more H. Of course, I cannot add H here, so there must be a split. So we would like to split it into half. So EF and GH. But now if there is EF and GH, then you would expect G to move to the top. So let's see. So EF and GH. So the G moves to the top so that anything above, anything that is G and above goes to the right of G. Anything less than G stays on the left of G. So I hope this is clear to you. Now if I add I should not have any problem because I have space here. So I go to the last one and add I. So this is not a problem. But what do you think happens when I start inserting J? Again, j is greater than g, so and it is greater than I, so I would like to add it at the end, but I cannot because of the max degree, so I have to split this node as well. But if I split this node, I should go to the top, but then here I don't have space for I. So now I have to break the root node as well. So let's see what happens when I do insertion of j. So I split the root node as well, and I take the middle element above. So let's skip back. So I have to split this root node here. So GH and IJ. So that means I should go to the top. So if I have CGI, I cannot have I here. So that splits this and takes G to the top. So let's insert J. So that takes G to the top. I hope this is clear to you. Now let's just look at the delete operation. So how do you, what happens when you start with a tree and you want to delete some items? So let's take the easier one first. So let's start deleting the last item. So let's start with J. So if I have to delete J, what would happen? I'll just come here, I look at J and I delete it, and that's as simple as that. So I get this resulting B plus tree. So everything is good about this B plus tree. Now what happens if I have to delete I? Okay, so let's delete I. So we removed I. So let's skip back. So I removed I, so there is no I here. So I don't. So what do I do here? So there is nothing over here to have a right pointer of, and I have G and H. So now I can split G and H, and then say that anything H and above goes to the right, and anything below H goes to the left. Right. So that's what happened here. So let's delete I again. So now I have G and H. I hope this makes sense to you. So let's do some more deletions. What happens if I remove H? So now if H is gone, uh, I simply have G here, but this doesn't make sense, right? So G to H and then H to G, and there's nothing more than H here, and H itself doesn't exist here. Now what do I do? Let's take a look. So I obviously want to delete G. So next what I do is I remove H and I put G instead here, and then make the right child as G. So let me skip back once again and let's remove H. So we are removing H. So this H and this H should go away, and I have G, right? So G should become right child of someone, right? That's what we are trying to do here. So we remove H, and there is a kind of rotation happening over here. So let me reduce the animation speed. Let's skip back and let's do deletion of H once again. So I want to remove H. So I reach to H, I delete H, and after deleting H, I did a rotation. So what did I do? So after I remove H, I would like to have G here, and anything that is G or above G should be on the right. So if there is G here in the root node, then the right should point to G, and anything that is lesser than G should be on the left side. So one way to do this is by shuffling things across here. Now how do I shuffle things across here so that I get that kind of a property? So basically what I'm trying to say is, I need something here on the root, um, whose right is G. So that means G should come over here. So the right is G and above. So right child would have G and above. But what do I put on the left side? So if it is G here and G here, what do I put on the left side? So I borrow one element from here. So let's delete H once again. So I delete H, I delete the root, I move the G, and I move the G here, and I simply go to the previous node, which was EF, and point G to that node, right? So skip back once again. So you see that I borrowed E from here. So I removed this E, so it became C. Okay, and we moved E, we made E as the root here. So let's, what happens if I just remove A here? Just let's try something different. So if I try to remove A, so I'm trying to remove this A. So let's remove the A. Now I have B, and B is lesser than C, and anything above C and above is on the right. So everything is good here. Let's try doing, just a second.